Hello, my name is Charreau, and I'm the Senior Data Scientist at the Data Science Institute at Vanderbilt University. Today's talk will focus on a hands-on workshop we developed in order to begin to address a particular issue, underrepresentation of people of color in data science. Improving diversity in data science begins with first building interest, confidence, and empowering students early in their academic careers. We present the details of a hands-on deep learning workshop where students can train a classifier that displays bias due to improper training sets with disproportionately poor performance on non-white faces. As we'll see in a few moments, the situation isn't rare or unusual, and models that display bias have been and continue to be used and have real-life consequences, particularly for people of color. In this introduction, we'll first start by talking through some AI currently used in society. We'll address some factors that may have contributed to the development and deployment of such models, and our approach to filling in some of the gaps that contributed to this. We'll then describe the workshop the students will participate in and what they'll learn. In our next session, you can feel free to ask us questions, and we'll also do a brief demo of the workshop. We'll also address the larger picture of how the workshop benefits all participants, even students who may not be interested in a data science career, to have a critical eye when evaluating or using AI models in their daily life and combat the issue of misusing this promising technology now and in the future. So without further ado, let's just jump right in and talk about some of the models that have made headlines, mostly due to their negative impact on people of color and minorities. Although we're talking about controversial models now to motivate our workshop approach, this is also a very important topic to discuss during the workshop with the students. As data scientists and non-technical leaders who will likely be using these models and models of these types to accelerate their workflow in whatever area, it's important to remember that our actions have consequences, and we need to take responsibility for producing models that are fair to everyone. Let's just talk through a few. Policing and recidivism models have been shown to get into positive feedback loops that increasingly negatively impact people of color. Let's take predictive policing for an example. Predictive policing uses location, time, type of crime, and historical crime data to predict where and when crime is likely to occur next. Certain types of data are included in the data set. For example, nuisance crimes such as vagrancy, low-level drug possession, and loitering are sometimes included. As the knee-jerk reaction goes, the more data, the better. However, if included in these models, these types of crimes can take up the largest volume. And it's really unclear as to whether the police should focus their efforts on these types of crime. Regardless, the effect of including these types of data creates a feedback loop, where the model is best able to predict areas where nuisance crimes occur, which then sends a heavier police presence to that area, which then ends up generating more nuisance crimes to be added, and the feedback loop continues. The unfortunate result of this is now that institutional racism is baked into the model. At the same time, though, race was never explicitly included. This makes people feel as if the model can be trusted, where really, the model performance is based on the training data it receives and is updated with. Recidivism models quite nearly suffer from the same types of positive feedback loop issues, and especially when combined with predictive policing. Recidivism models predict the probability of becoming a repeat offender, and it's used to determine sentencing and parole. The data sets upon which these models are built include factors such as criminal history, address, number of stops by police, and how many of the individual's family or friends have been convicted of crimes. In order to avoid the appearance of racism or classism, these models don't tend to include race or socioeconomic status. However, with the variables that are included, they often serve as proxies for demographic information, and the information is now still baked into the model. These models end up disproportionately punishing Black men, particularly those who live in low-income neighborhoods, are far more likely to have encounters with police or have family members who have, especially when compared to white people or residents of suburbs. These are just a few examples, but there are many models used in practice that have been demonstrated to be biased. You know, here's a question for you, and actually one that's really important to ask the students as well. Why do you think these types of models were created at all? Do you think that they were created with the intent to produce this type of biased behavior? The potentially optimistic and hopeful answer is no. These models were likely conceived in good faith. In fact, they were likely created to combat human bias in policing, the justice system, hiring, medicine, and other application areas. How can a computer be prejudiced, right? Practitioners and policymakers believe that through using data and data-driven techniques and models that don't have this subconscious bias, they could reduce their bias in the decisions and make more optimized decisions. To bolster further this level of fairness, they removed obvious indicators of race, gender, and other factors in order to achieve more equitable outcomes. But this isn't what happened. And due to these prevalent and relatively intuitive beliefs, we arrived at models that are having a real and unjust effect on certain subsets of our population. Even further, some of these models are actually deployed and in use. What factors went into these models being trained and deployed, and why did people adopt and believe them? One of the contributing factors is simply just a lack of diversity within the data science field. The people who are likely to have experienced inequity due to systematic and institutional racism are not necessarily represented during the formulation and testing of the models. Another huge contributing factor is blind trust in these models. We said before, how could a model be prejudiced, especially when we don't give it any demographic information to learn about? The answer is, we end up encoding our own societal biases on the information that we give it to learn from. The role of the data set that the model is trained on is pivotal, which is made obvious by the policing, recidivism, and other models that we've talked about. Selection and reporting bias have a huge impact in this space. Often, humans are responsible for generating the data from which the model learns, so our biases are included within the data set. If bias affects doctors so that they subconsciously treat particular demographic groups in different ways, the data will reflect that, and the model will learn from it. If current and historical policing trends unjustly focused on targeting minorities in certain neighborhoods, this will be reflected in the data, and the model will learn from it. If police don't report certain instances of crime for some subsets of people, but treat it as crime for others, this will be reflected in the data set, and the model will learn from it. Future data scientists and other policymakers should be trained in critically evaluating the data upon which the model was trained, because biased training data will easily bake human biases into the model. Furthermore, practitioners might even fall prey to confirmation bias. They look at how the model performs, and it is consistent with how they expect it to perform given their own implicit biases and expectations due to societal conditioning. The model is sending police to a particular neighborhood all the time. They think, oh, that makes sense because that neighborhood is high crime. We have to think critically to avoid these problems. The last component really follows the other two, which is a failure to examine model performance in terms of the demographics of the people whose lives the model will affect. Historically, data scientists have been trained to look at overall model performance, so AUC, confusion matrices, precision, recall, etc., to determine what is a good model. But a model with great overall performance can perform very poorly on some subsets of the data. This concept should become ubiquitous in data science training programs. So what gaps did we have in training future data scientists that led to these issues? In terms of diversity, we need to illuminate the work of data scientists to younger students so that they can be aware that this role exists and what we do, how it impacts them, and how they can start a career in the field. We can also try to tailor our approach by providing enough training to empower students to continue to investigate on their own and remove some types of technical roadblocks. For example, a really great computer, a GPU, knowledge in the area, and lack of confidence. We can start to remove these types of roadblocks from their paths. Secondly, we need to actively combat the blind trust assumptions, mostly because it feels very intuitive. People are unaware of the general context in which modeling occurs, which leads to their absolute belief that AI models are fair. Lastly, we need to demonstrate ways to examine model performance so that models can be fair to everyone. To take one step towards addressing these problems, we've created a GitHub repository focused on developing skills in data science with a focused eye on ensuring that future data scientists think about the application of their work, whether it be in internal business intelligence, marketing, human resources, public policy decisions, or wherever the models are applied. The benefit is twofold. First, students that are interested in data science will be provided tools that they need to perform data science activities while also thinking about the broader impact of their models. Secondly, students who are not so interested in data science or who will not go into the field, but will go into other fields, will receive first-hand experience about the models that they will encounter with a critical eye towards performance. So in order to learn all of these things, what will the students actually do during the workshop? Well, first, they'll use our publicly available repo to go through the canonical data science steps. They'll collect data, they will train their model, they will then use the traditional evaluation metrics of model performance, and then based on this, they'll discuss with each other whether they would accept this model into practice. Then we'll actively engage them on the concept of model fairness. And we'll review the model performance based on demographic subsets. We'll identify and diagnose the problems, and then the students will reevaluate whether the model really is suitable based on their performance on these subsets. We'll then introduce ways for them to improve the model performance for everyone by deeply reassessing the training data and train models and iterate on the data until they produce suitable performance. Now, how does that begin to address the problems with AI fairness and the gaps in training that we've identified? First, students are empowered by working both alone and in groups to solve a particular problem using industry standard data science tools. Our workshop is suitable for people of all skill levels and particularly suited for beginners, and they'll be introduced to data science. Secondly, for people of color and underrepresented groups, they'll see that data science and STEM isn't just for others, it's for them as well. They'll also learn through the hands-on training and analysis of a data science problem that they may find interesting. Secondly, we'll begin to dissolve these blind trust assumptions so that future data scientists can learn about their ethical responsibility in producing fair AI models, and lay people can critically assess whether they should trust, approve of, or use certain models based on their performance. They'll experience firsthand how important the data set itself is in training the model, and they'll learn responsibility in assessing model performance and in retraining models to meet equitable outcomes. With a guided hands-on experience in data science, we'll lower some of the roadblocks that some students may feel about data science to address the lack of diversity. Sometimes, just figuring out how to get started with the vast expanse of resources available can be overwhelming. In our workshop, students will learn the basics of data science and the data science methodology. Gaining knowledge of the data science process also helps address the blind trust assumptions. Data scientists regularly make executive design decisions in training the models, and these also have an impact on their performance. Related to the last point, A second part of lowering roadblocks to enhance diversity comes from guided exploration with industry standard tools. Our workshop will empower students to use these tools by building familiarity with some of the most ubiquitous ones and form a solid foundation upon which students can learn and grow. For future and current data scientists, we always need to keep in mind that the application of our model will have consequences. We and other policymakers always need to consider what our evaluation metrics will mean when the model is used in practice. We need to be cognizant of the impact of what we will do, and we need to train others to do this as well. Our workshop will address some of the gaps that we've identified, which contributed to the use of unfair AI, and will encourage diversity so all may benefit from what technology has to offer. Thanks so much for coming to our seminar, and please feel free to ask us any questions you have about our approach or our workshop. In the next session, we'll do a bridge demo of our workshop, and I hope you'll bring along your laptops and live code with us. See you in the next session.